right, hello there, grade sixes. I am currently set up in the multi-purpose room to film our aerodynamic station. I've got all of my supplies, I've got my experiment pages, and I've got my textbook ready to go so I can follow the procedure. This is the work on it from page 189 in the textbook up to page 192. Now, a lot of these experiments are easy ones you can do at home. You can use scrap pieces of paper, cue cards, pop cans, a straw, basically anything that you need for this experiment, you would have available to you at home. So after you've watched the video, if you wanted to go home and experiment, try these out, show mom and dad, somebody at home, younger sibling, explain to them what you learned about aerodynamics with airspeed and air pressure. This is definitely something, an easy one to do at home. All right, let's get started. This is aerodynamic information station number 1, levitating lips. I've got my piece of paper. Make sure you guys start with your prediction. So holding it up to your lip. As you increase airspeed over top, you're blowing air. What do you think is going to happen to that piece of paper? Make your prediction first, and then we'll get to the observation. So I'm increasing the airspeed over top. So I've got higher airspeed on the top. Which means I have lower airspeed on the bottom. So then where's the air pressure? Greater. Higher air pressure is pushing what direction? Complete those questions. What was the speed of the air above the paper compared to the speed of the air below the paper? How did the paper move? Where was there more air pressure? Remember, air pressure pushes. So if that paper was rising up, then where was there more air pressure? Make sure you do a little sketch, draw your best Mr. Bond you can, and then we'll move on to the next one. All right, next one, we have aerodynamic information station number 2, moving air. So we've got our folded cue card. So start with your prediction. Use your information from the first experiment to maybe make a little bit more educated of a prediction. If I am blowing air underneath the cue card, creating higher airspeed underneath, then where is there going to be higher air pressure? Where is that higher air pressure going to push? Write down that observation now. Observation time. Sorry, that was write down your prediction. Now it's observation time. So that airspeed is higher underneath. Trying to create as much as I can. Ready? One more. So, write down your observation. What happened to the card? Once you're done your observation, move on to those questions. So in step 2, what was the speed of the air above the index card compared to the speed below the index card? Where was their high speed? Where was their low speed? What direction did the cardboard move when you blew under it? Did it move down? Did it move up? Sideways, forwards, backwards? What did you observe? And where was there more air pressure? Where was the air pressure pushing? Was it pushing up? Was it pushing down? Again, give a quick little sketch. On your sketch, you might want to label the cue card. You might want to label airspeed, air pressure. Up to you. Be as detailed as you can. I'll give you maybe a minute or 2. All right, moving on to aerodynamic information station number 4, uncanny movements. Now that we've done 2 experiments, now your predictions might have a little bit more justification to them. You might be making a little bit more accurate of predictions. Now that you're starting to figure out that relationship between high airspeed, low airspeed, with high air pressure and low air pressure? Which ones are connected together? So for this one, 2 pop cans and a straw. I didn't have a straw, so I made a nice little cue card straw. So hopefully that will work just for us. So 2 pop cans, I'm going to increase the airspeed between them. So what is your prediction? Are those pop cans going to float up in the air? Are they going to go out? Are they going to come in? Are they going to do something else? What is your prediction? Think back to those other experiments. How was the area of high speed related to air pressure? Observation time. What's happening to them? Oh. Works without a straw too. Gotta increase that airspeed. So write down your observations. Did the air pressure push them together, or did the air pressure press them out? Part of that air pressure pushing them forward obviously is because I'm behind them as well. Where was the air moving fastest? Between the 2 pop cans, bring these back, between the 2 pop cans or outside the pop cans? Which direction did the cans move towards? Did they move towards the area of high pressure, or did they move towards the area of low pressure? And where was an area of high pressure? Was that high pressure coming from the outside pushing in, or was the area of high pressure on the inside pushing out? Draw your quick sketch, include your pop cans. Mr. Bond, include your area of high speed and low speed, include your area of high pressure and low pressure. Moving on to the last one. All right, for this last aerodynamic information station, number 5, temporary attraction. So I've already got my ruler with 1 piece of paper, 2 pieces of paper, and I just tape them together on the top. So as they sit there, they keep that couple centimeter gap. So now if you read through the information there, we're going to increase the airspeed between those 2 pieces of paper. So we'll have high airspeed in the middle. Now, taking our information from our first 3 experiments, now your prediction might be getting closer to being correct. So what's going to happen to those pieces of paper? Are they going to go out? Are they going to go in? Are they going to fly away? Make your prediction now. Observation time. So as I increase the airspeed in the middle, what is that higher air pressure doing? Where is that higher air pressure pushing? Write down your observation. What did you see? Move on to the questions. Where do you need to direct the air? Where was the air moving the fastest? How did the paper move? Where did the air have the most push, or where did the air have the most air pressure? And we will skip the step number 2 using a thick straw, but I do want you guys to move on to the sketch as well. Once you are done, I have my papers here with me. Once you are done that, we can work on communicate number 1 and 2. Okay, thanks guys.